rectangular coordinate system, because this is something that we will be looking into. An n space denoted by the domain real numbers. So you know that this is the domain for the real numbers, to the superscript n. So denoted by r to the superscript n, has n dimensions with real coordinates. R1 is a real number line. Okay, so this is a real number. So we know real numbers are negative numbers, positive numbers, integers, decimals, all of them come under real numbers, right? So now they're saying that it has n dimensions with real coordinates. Okay, and here's your number line. This is your x-axis, and you go from 0 to infinity on the positive side, and you go from 0 to negative infinity on the negative side. And then r squared, or r to the superscript 2, is a real plane. So you have it's a real plane. We know that it's a 2-dimension, right? So we have an x-axis, like for example this page is like a 2D. I mean, it's not exactly 2D, but you know, something which has a flat surface. It is a plane. And r3, like for example the space in which this pencil is moving, is a real space. There's 3 dimensions to it, right? So we know that it has a point x, y, and z coordinates. It is impossible to draw an accurate coordinate system of an Euclidean space with n greater than 3. Or in other words, if your dimensions are more than 3, for example 4D, like you know, it was hard to envision that. So it's impossible to draw 4D because we can only see everything in 3D, right? So anything with where the dimensions are more than 3, it's hard to draw a system like that. However, the points in n space can be represented by vectors, like you know, xn1, x1, x2, x3. So you can have, say, a 4D, and you can represent the points as x1, x2, x3, x4, right? So you can represent them by vectors, and the rules of vectors can then be applied. So they're saying that it's hard to draw a 4D or a 5D or a 6D, but then you can represent them as vectors and say, here's a vector in this space, in n space, and it can be represented as p of x1, x2, x3, right? And so what are some of the rules that these vectors have to follow, right, in n space? So we're going to look at those rules. The vector n space is a space in which the points are represented by n vectors, okay, which meets the following criteria. The n space is closed under vector addition. The addition of 2 n vectors returns an n vector, and the scalar n for, so in addition, the addition of 2 vectors returns a vector. It's not like when you add 2 vectors it becomes infinity or anything like that, but it is closed. Okay, so 2 plus 3 will only give you 5. So it is a closed addition, right? So vector addition is closed and it returns an n vector. So scalar multiplication, the multiplication of an n vector by a scalar returns an n vector. So if I have a vector, say 3, and if I'm multiplying that by, say, 2, which is my scalar, the result will be the result will be an n vector. Okay, it returns an n vector, so I'll get a vector with the value and magnitude 6, right? So in what they are trying to say is vector addition and multiplication, it remains closed even in ND, right? I hope you get that. And then the n space defines the basic operations. Okay, remember when we were doing, I think it was, I don't remember which booklet it was, but remember when we were talking about reflection, rotation, translation is like when you're like, you take something and you magnify it, or you take something and you reduce the size of it. That was translation. And then when we take something and rotate it, like if there was something like this, we rotated it like this and we tried to draw it. I forget which booklet it was, but I'm pretty sure it was like a few weeks ago. So the translation and rotation, translation is accomplished through vector addition and rotation is accomplished through the dot product. Okay, we will get into this more as we work through the booklet, but I want you to know that this is mentioned here, so we're not looking for where is this, what are they talking about, right? Okay, and then the n space obeys the following laws. If you have vectors u, v, and w, and the scalar quantities a and b, what are some laws it follows? So we know the commutative law, a plus b equals b plus a,